In this video, this follow-up video, we're going to take a look on how to determine the numerical value of a rate constant given the general rate law equation. And we're going to take a look at the data that we had in the previous video. We have a hypothetical reaction, A plus B going to C. We've already determined that the reaction is second order with respect to concentration of A and first order with respect to the concentration of B. But now let's find the value of K. And to do that, we just simply plug in, we pick any trial, and so we're going to pick any trial. I'll pick the first one, trial 1, and plug in some numbers over here. We would get the same answer if we picked trial 2 or trial 3. So trial 1, we have the rate. Okay, let me write the general equation here. Rate equals K times the concentration of A to the second power, the concentration of B to the first power. The rate is 5.0 molarity per minute equals K times the concentration of A, which is 0.10 molarity, and that's going to be squared to the second power, times the concentration of B, 0.10 molarity raised to the first power. Let's go ahead and do a couple of steps over here. 5.0 molarity per minute is equal to K. And this is going to be 0.1 times 0.1 times 0.1. That's 1 times 10 to the, so that, well, the decimal value of this would be 0.0010, and the units would be molarity cubed, okay, K times that. And now we go ahead and we're going to solve for K, so we're going to move this all over here. Now you'll notice that I have a molarity on this side and a molarity cubed on that side, so I can go ahead and do some simplifications, but let's go ahead. Let's divide both sides by this 0.0010 molarity cubed, 0.0010 molarity cubed, and now we get a final value of K equals, and that's going to be 5,000 molarity over molarity cubed is molarity squared in the denominator, and that's going to be minutes in the denominator and molarity squared in the denominator. This also can be written as K equals 5,000 minutes to the -1, let me clean that off, molarity to the -2. And as far as significant digits go, it looks like we have 2 significant digits throughout. So reality, this one, we really should report this as K 5.0 times 10 to the third minutes to the -1, molarity to the -2. And that would actually be the best value. So now our final answer is, our final rate law equation is that the rate of the reaction is equal to 5.0 times 10 to the -3rd minutes to the -1, molarity to the -2, times the concentration of A to the second power times the concentration of B to the first power. This is our final answer for the rate law equation for this hypothetical reaction.